Everything is good? I'm not muted? Okay. 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 So good morning. So I'm Hervé Lemaitre, so I'm gonna present presentation titled Practical fMRI Analysis. So doing the presentation, I was wondering, and I realized that so this presentation will be an introduction for the practical course of this afternoon. And then when I designed this presentation of 1 hour, so I realized that I will not talk a lot about fMRI during this hour. So it will be everything about fMRI will be during the afternoon. So the reason for that is in the title there is practical and fMRI. So I'm more a practical guy than a fMRI guy. So the idea, and I will make an analogy with cooking. So I will not teach you how to raise or to grow a garden. So what I want to teach you is how to cook your tomatoes and your broccolis and everything in your garden. So that will be, there is two goals in this presentation. The first one is to give tools to process your fMRI data or any kind of neuroimaging data, and also to provide a framework. Like I say, I want to provide tools like the spoon, the fork, the span for cooking, but also to give you the kitchen with it and how to deal with it. So that's it. Cooking so yes, I will focus more on the practical aspect of it and less on the theoretical aspect of fMRI. So I'm not physicist, so I will not go deeper in it. So for this afternoon, that will be very basic fMRI tutorial. So if you are already expert in it, so you can join, but it will be very basic. So it will be a springboard for what you will learn after. Okay, and so yeah, I didn't click on the video. Yes, that again, the idea is to put everything in a box. You check it, okay, at the end, and you get your results. This is the global aspect of my code. And so what I want to provide is what is inside the box, but also the box, the framework. Let's. So that is just a reminder for this afternoon. So I will go at the end of this talk. I will go over the NeuroDesk installation for those who have not done it, and if they need help. So I will try to solve that. So you need a computer for sure. So you can share also the computer with someone if you don't have it. You have the Wi-Fi that is set up, and yes, you need to install NeuroDesk. So that will be the framework. So before we start, I want to know you. So what I'm gonna do is to start that. And we are gonna play a little bit. So let's do a little bit of a little wool clap. Uh, so just to get a sense of what you people are doing, what's your expertise, and what are you familiar with. Um, So let's start. So everybody, so you can scan or you can go to Google and type this code if you want to do it on your computer. Ready? Ready? No, I'm still seeing people trying to get the QR code. Last call. No, not working. So let's start. Okay. So the first question is, so that will be very practical, as I said. So which operating system are you used to use? So let's see. So we are around 30 people in the room. So we don't forget to click on the validation button because some people forget to do it. So mostly Mac. Okay. Okay, you will see it's not really, it can be important or not. So, because when you process data, you are familiar with a certain kind of operating system. It's better on some of the operating system, less good or not, but you can adapt what you are doing. And it will be a point in my talk on that. Okay, so Mac is the winner. Let's say that. Where is my mouse? No, okay. Okay. Are you familiar with Bash command line, let's say? No. So again, new imaging softwares are not designed to run on Windows or Mac per se. So at the beginning, it was more command line based, but now there's a lot of software using GUI or graphical interface. So it's really, okay. So most of the people are used to do command line. Now, are you used to code? So coding experience? No, yeah, no, no. Yeah, I should have put the question on it. What is your expertise in coding? But there is the following question, so I will know. Okay, again, so using code, Python, for example, it's very useful. So now it's free for you to answer. So there is different languages, so more some people are more familiar with some languages. So yes, Python, Python. What is this one? This is the top. There's two Python. ChatGPT is not a language. MATLAB, yes, R. So yeah, currently Python is one of the most dominant language to do neuroimaging because it's a really versatile language. MATLAB is good, but it's not great. Java is okay. Someone is doing Java. Okay. Nextflow, I know the guy who's doing Nextflow. Okay. And yeah, so none. Okay. Uh, are you familiar with neuroimaging data? So is it your first experience coming here to play with neuroimaging data? Some people are free of bias, let's say. Okay. Okay, so I put some modalities of neuroimaging. So SMRI is for structural MRI, functional MRI, diffusion MRI, and I didn't put all of them, so but other is possible. Okay, so the winners are maybe fMRI, diffusion. Diffusion is winning, maybe. No, it's a win-win. Okay, mostly diffusion and fMRI. Okay. Okay, now, so again, so to process fMRI data or neuroimaging, let's not talk in general, so not fMRI, but to process neuroimaging data, are you using a typical software so you can enter your news? Okay, so yeah, there is, so we'll see that also there is, for example, for fMRI or even for neuroimaging, SPM is one of the big three. FSL, fMRI, right? So there is some packages, library in Python that can be used for brain, okay? Good. Okay. Okay, so now it's specific to fMRI data. So are you familiar or not? Let's say my tutorial during the afternoon will be very basic. So we'll see some uh, single first level analysis, and we'll see also functional functionectome. Okay. Yeah. And again, so are you using a specific software to process your fMRI data? My, yeah. Okay. What is it? It's a good choice. Don't do it. Okay. Okay, just yeah, it's give you an overview of what you can do. So I think it's the end of yes. Do you know Neurodesk? So it's what I will introduce today. No, okay. Yes, only 6, 7. Okay. Okay, I know. So we will see that. So hopefully at the end of this talk, you will know about Neurodesk. Okay, I think it's over. I don't have any more questions. Yes. Okay, no more. Oh, thank you. Okay, so let's go back to the presentation. So it's a way to introduce what I'm gonna talk. If I can go back to my presentation. Okay, that I've done it. Okay. Okay. So let's introduce what I'm gonna present. So if I want to take practical fMRI or practical neuroimaging. And so if we talk about practical, that means how we do neuroimaging studies. And so we need to talk about open science also and reproducibility. It's what I want to talk about because when you start to do neuroimaging, I remember that when I started to do research, my only goal was to process the data to get the results and to publish. But reproducibility now is a big thing. So let's define what is reproducibility. So if I take this definition, reproducibility is the ability to obtain the same results as a prior study using procedures that are closely matched to those described in the original research. So should be good to be able to reproduce data. So that is the first point. There is so some people talk about replicability, other people talk about reproducibility. Reproducibility is there is a small difference. Reproducibility, you take the same data and you try to reproduce the same results. Replicability, you take another data set and you try to replicate. But let's talk about reproducibility for this talk. So in around 2010, there was this what we call the reproducibility crisis. So I was doing my postdoc at the moment at this time, and it get clear attention as it touched firstly the psychology and society science. So researchers started to say, yeah, there is a lot of studies that have been done on a small sample. Let's try to redo them. And what happened is that they were not able to do that because bias sample, not the same methodology, and so on. And that affection, let's call it like that, touch the neuroimaging field just after. The main reason is that at the time, we were doing neuroimaging with a very small sample. So again, not population based and very difficult to reproduce. And so not talking at the same period, we had this double dipping affair, let's say, where so people knows about double dipping. Okay. So it's when you take your fMRI data, you get results and you reanalyze them again. So there is a bias So you conduct twice the same analysis and you reduce the statistics to get what you want to show. Let's put it like that. So yeah, so that was happening. So so as I said, it was 2010. Now we are 2025. So it should be over. But surprisingly, it's not. We are still in crisis, and so for different reasons. But the pressure of publication is here also, and as the number of publication continues to grow, scientific papers, not all of them, but a lot of them are advertisements, so they don't care about reproducibility. So we need to be careful. So we are still in the time where we need to be careful about reproducibility. And again, so one way, and I will talk about it to bridge this reproducibility crisis, is to share raw data and experimental materials. And it's not always the case since now. Okay. And so, yeah, how can we make research reproducible? So there is two sides. So you can share data and analysis code. So when you do conduct analysis, you can share your data, and like that, people can use them and reproduce. And also you can use share data and open source tools. There is two things, data and tools. So I will come back to that. So you can share your data, which is the first step, but also the scripts, the procedures, everything you do, you can share it. And also your results can be shared. So just a comic. When you want to share data, it's just to feel all these aspects of your results and not to just say that a miracle. A miracle occurs in the middle. So sharing your data, you will close the gap of all these problems. So how to share data? So using, so a bunch of people think about it and say, yeah, let's put some principle how to share data or tools in general. And so they ended up with a FAIR principle, which is a set of guidelines designed to improve reproducibility, transparency, and reuse of digital research objects. So the FAIR stands for findable. So data and metadata should be easy to discover using persistent identifiers and searchable resources. So yes, you put them, your data, you put them somewhere where people can find them. So you can use now, there is a lot of repository where you can put your data. It should be accessible. That means when you put these data somewhere, you need to be, so if they are open accessible, it's good. Or if there is some restriction, you need to clearly indicate these restrictions. Interoperable, that is really important. So if I give you, which I did during my postdoc, I took a USB key, I put all my data on it and give you, yeah, everything in there. You can process them, you will get your results. You come back 1 year later, you open the USB key and you don't know what is inside because it's organized like a dump thing. So you need to be organized in a way. So you need to, data should use standardized format and vocabularies so it can be combined and used across different systems. And last one, the R, reusable. Data should be well documented, licensed, and described. That is important. Like the example of the USB key, if I give you, yeah, all my subjects on it, and if I don't give you their age, sex, on all the information of the data set, the experiment, it will be not usable. Okay, so this afternoon, we'll use data that are openly accessible. And so where can you find them? So one way to find them is to use OpenNeuro. That was the former OpenFMI, if I'm not mistaken. So yeah, you can see at the beginning of the 2018, on this platform, there was only 200 data sets and just a few subjects. Some subjects, and now we are, so that stop at 2022, but if you go to the website, which is here, open it. Yes. Uh, yes. If you go now, we are close to 60,000 subjects and 1,400 datasets. So you can go on this website and you can download. If I go here, yeah. Ah, yeah, you can find data on EG, MRI, PET, MEG, AG, and all these stuff can be found openly accessible. So that was, can I go back to my presentation? No, is it possible? Okay. Okay, go on. So yeah, so I talk about standardization. So now in new imaging, we use the BEADS standards. So the brain imaging, so BEADS stands for brain imaging data structures. It's a sample and amplitude way to organize and describe your imaging data into data to simplify it efficiently. So at the beginning, when you get your data from the scanner, for example, it's the format is DICOM. So it's organized in a way that is a folder with a number, and inside you have a lot of files. And it's not really simple to get a sense of what is inside this folder, because even all the scans are not described in it. So it's a DICOM folder with all the files. So the way of doing BID is just organize your data set. So you have a data set, you put a TSV file, which is tabulated separated value, where you put the name of the, not the name, the code of the participants, all the information, and you separate one folder per subject with the anatomy, the functional, and you put the images like that with a JSON, which gives you the indication of the sequence or all the parameters used for this scan. So it's a way to, like that, when you give the USB key or when you get data, it's always organized the same way. And like that, we can use software that can directly access this organization. So there is a lot of rules for different modalities. Now it's pretty simple to organize. There is always software. There is also for software to organize your data automatically, which is good. So fMRI analysis. So I ask you about the software you are using. So here I'm showing some of these softwares, like the big trees, AFNI, FSL, SPM. So when I started to do new imaging, there was not plenty of them. So just mainly these three. And people were mostly using. Now there is a bunch of software. So yeah, I saw fMRI prep so in your answers. NiPipe is a, and I did this plot completely arbitrary. So here you have the flexibility, which is what I call flexibility, but in a way that is more configurable, more graphical friendly. And there is reproducibility with more standardized and more automatic. It's completely arbitrary because you can do, in fact, the same. You can be very reproducible with SPM, but it's not made for that. And also you can be, it's not flexibility, but you need to be aware how to tweak with this, for example, to get what you want. And I have forgotten another axis, which is the expertise you need to use this software. So for example, SPM was designed to be, you click on the buttons and you don't need to write command lines. And fMRI by default, there is no graphical interface. You need to know how to write the code. Okay, so let's take an example of reproducibility, how it can happen that your results are not reproducible. So that is an example where you do fMRI, you are on the Mac. So everybody is using Mac. You use Christopher or SSL. So the Mac OS is using library or packages that are inside the system that is connected with the software you are using. So you are doing all the stuff. You are your results. You describe your scripts. You write everything. It's like, yeah, it's very reproducible. Do it and you will get the same result. So you give the code to someone else. And this guy is using Ubuntu. Is using not the same version of the FSL, not the same packages, and you will not get the same results, even if you made the effort of doing things reproducible. So you need to be careful of this pattern. And there is a lot of studies or articles. I didn't put them here, but they're showing that doing neuroimaging in one framework and you don't get the same statistics if you are not using the same OS or same packages, which is a problem. Yes.
Somehow.
The what?
For the like in the lines of open science, is this somehow reported, this combination of softwares and what the output may be because of that?
Normally, you should report the version. Yeah, it's not very clear what you should report. So in an article, for example, you report the version of the software, the packages you are using. But if you don't report them, so sometimes it can be difficult to. So that was your question?
Yeah, I wonder if it's in the guideline, for example, like you were mentioning before, the guidelines also cover this kind of aspects. It may also be.
Yeah, the more you report, and it would be better. Yeah.
But it's not.
It's depend on the people using you. Yeah, so we are still in the way of doing reproducibility. So people are doing it, and some people don't care. So it's and what I show you for the FAIR principle, they are for the data for sure, but they are also for the tools. Okay, so the tools should be the same way as the data, so very well organized, and should report all the modification that have been done. But yeah, we are in the process of doing it. So. And so it's why I'm talking about that, because we use NeuroDesk today. And so just an example how you can use a platform to kind of remove all these problems of responsibility based on the OS, the dependency of your OS with the software you are using and the data you are using. So NeuroDesk is an open source, which is good. You can show what is you can see what is inside. It's a container-based platform. Container means just so I don't know. Some people are aware of what is a container, but container is like a box or a computer inside a computer. So you run a computer inside a computer. So it's a way to isolate all the problem of dependency, because this container is independent of the operating system you are using. So it's a good way to remove all the problem of dependency. It's for neuroimaging analysis. So it's really dedicated for neuroimaging. So I will show you. So there is 4 characteristics. So it's accessible. That means it manages dependencies and different operating systems. So you can run it on different operating systems. It's compatible in a way it's stable. So as I showed you, if you move to one OS to another one, it will not change as it's independent. It's a container, so it will be independent, so stable across operating system and updates. It's portable, so I will show you the different version of portability of this NeuroDesk. So you can use on your local machine, you can use on the cloud, or even on the clusters. And it's easy to run. Easy and you need to install it first, but after it's easy. So because just before Steph is here, so she was trying to install the thing. It's okay. So it's 2 steps, but okay. So it's another way of putting it. So with NeuroDesk, what you can do is you can import your data using OpenNO, OSF, data lab, everything. You can process your data. So I will show you. You can use all the software you can on this container. You can organize your data. So it's mainly using Jupyter Notebook. So it's a way of registering, storing your scripts, all the recipe. Like if I do the analogy with cooking, you follow a recipe, and if you do a new recipe, you can put everything in your Jupyter Notebook, and you can run it on this container. It will redo the same thing, exactly the same one. And after you can share the data again. So it's simple. So this guy, so this Neurodesk was developed. Sorry, I've forgotten to say. Yeah, it's a team in Australia. It's Stefan Bollman who is developing with his team this Neurodesk. So I put so I asked him to run it. So there is a version for tutorial. So I asked him if I can do it. So we will try to use it. And yeah, he told me yeah, there are low in resources, so donation are accepted. So I told him that I will make the advertisement for it. So, okay. So yes, at the middle, you can run it locally. You can run it on clusters and also on the cloud. So I will show you how to run it on the cloud and on locally too. It's a not heavy container because as it's a box, like at the beginning of the video, I will provide the box. It's a box of 2 GB, so which is not easy for all the softwares in it. And again, if so, there is all the softwares in it, but there is no limitation to install a new one. And we will do it this afternoon. For example, with the functional clone, you can install it on it and it will work. So I think it's good for reproducibility. That was my point for this talk, and it's also good for pedagogy because for tutorial you will see there is a graphical interface. You can give it to someone that will get the same interface, and it's really good. I hope this tool will be used more and more, and we'll see that. Okay. Yes. And if you want, so I'm gonna show what is the time. So I have until 11:30, something like that. So we have plenty of time. So if you are interested in this kind of reproducibility framework, and I had this question because when I presented myself, I'm doing population imaging, so we are really working on this reproducibility and how to analyze large data sets. So there is this book which I'm editor where you can again, very practical, where you can see different methods for analyzing large neuroimaging data sets. So it goes from fMRI, DTI, structural, and it's put in a way that, yes, it's scalable at a level of 1,000, 2,000 subjects. The point is that how you can process from, if you are used to process 10 subjects, how can I do 1,000? Okay, that's yes. So now let's a little demo of it. Mm, Can I? Okay. So if you followed Michel, can I put that here? Yes. Michel instruction in his email. Why is my mouse? So there is two things. So I'm using it on Windows. There is instruction on the web page of the Neurodesk. You can so you need to run Docker. Docker is a kind of layer that you can use to run containers or virtual machine. So you need it to install it. There is different version for the different operating system. So normally mine is running. Mine is running. And normally when Docker is running, you just need to run the neuroapp. So let's see if okay. So normally when you run Neurodesk, you will see this window. And again, so I will use the local version of it. So if you don't have Docker, you will see failure and it will recommend you to install on Docker. So something I noticed just at this morning. So it should work. See, we have a white screen like that. So good. He will tell you at the beginning that he needs 40 minutes to run the first time. So I recommend for this afternoon to run it the first time before this afternoon. Wait, it's not working. Okay. So you need something else. You need a little bit of space on your computer because it will. So the container is 2 GB, but for this afternoon we will download in it some data sets. So it will be around 10 GB of data and processed. So I'm seeing some people that are maybe don't have 10 GB on their computer. Yeah, seems to. I'm here. So, okay. Now, yes, now this should be like that. Okay. So when you open it, yeah, no, not yet. Is it? Okay. So when you open the Neurodesk app, you will see this window. And this window. So if you want to run the Node desktop, this is on this, you click on it. So as I said, it's using mainly Jupyter Notebook. So you can run your Jupyter Notebook here and you have different, so you can access it through a terminal. You can use Markdown files. So Markdown file is a way of reporting your data and use command lines in a way that other people can use it. So, okay. So when you click on it, you should see. So I will go over people that don't have these windows after. That's used to you. So, and it will open something like that. So it's a way to access your container. So you can use both of them are good. So you remote desktop um, or VNC. Two times. I'm not used to use two screen like that. Okay, so I will use this one. Yeah. Okay. And you're on it. So it's pretty straightforward. It's a computer. So you have your desktop and you have, so it's Linux based. So you have a menu. You can use it like a regular computer. So let's me try to do from here. So you have a menu. I can access it. So let's see something that will be easier for me to manage. I'm gonna have to clone my screen, right? That will be easier. Ah, yes. Oh, let's share again. Screen that I will be. Okay, and it should be. Okay, so you can see. So it's a desktop. So as I said, I don't see my screen. Why? Zoom is not responding. Okay. Good. Okay, let's go back. So as I said, so it's a desktop. And so if you go there, you will see that you have a bunch of software. So if you want to do diffusion imaging, you can use FSL, Some of them I don't know, but yeah, there is a bunch of softwares, Ematrix. Everything is pre-installed, so you don't need to install anything. So everything is on it. For functional, yeah, the same thing. So it's what we will use. We use FSL. So there is different version of FSL. You can use the recent one or the oldest one. You just need to click on it. So it has a shell on it. So it's Linux based, I think. So uh, you can run it. Say I want to use FSL eyes. Normally you should open it. So after it's a container, so it's not a big computer inside a computer. So you need to use the resources of your own computer. So it can be, so if you have a big computer, it will be faster. But the advantage is you can deport it or deploy on cluster if you want, because it's like a container. So you can put in a cluster, multiply it, and run all your analysis by command line. So it's can be efficient. And as I said, it's for tutorial, it's very good because yeah, I can show you how to run FSL and all the things. So it's what we will use. Yeah, for me too, I cannot read. Is, zoom in. But yeah, just an example of a shell here. So it doesn't, yeah, just type FSLIs and after you have FSL and you can run. So you didn't install FSL on your computer, but you have FSL already on it. And you can, yeah. Okay, so that was the example of the local, wait, sorry. That was this afternoon. That will be this afternoon. So your data will be on the container. So for example, at the beginning, yeah, still yes. So here, the storage is here, for example. The container is there, so you can put data. So if your data are on your computer, you can put them in the container and just copy your paste, and drop them in the no desktop. Can you map the folders like the filter? Yeah, so that this is already mapped. So this one. Yeah, but like instead of copying to the bottom, you can make links, but yeah, you can make links, but I didn't. Yeah. But do you have? So it's running with Docker. Yeah. When you start the instance, and you say, I also want to map another access, yeah, it's all the folder. Yeah, you can click it as you want. If you want to add some, yeah, some link to a folder or a subdirectory in your computer, or even a remote, yeah, you can do that. So what we will use for the data this afternoon, we will use data lab, but I will explain you what is data lab this afternoon. Okay. So that is the local version of it. So you need Docker and your desk. But what is cool about it? So let's close it and let's go. So what is good? Yeah, you can close it. You reopen it. It will stay the same. So it will not change during the night. Okay, let's close it. Okay. So what is good is that so that's something else. But if you go to Neurodesk Play, there is a website where you can run directly Neurodesk in your browser, so you don't need to install anything. So we are in Europe, go there. So for that, you need a GitHub account. But when you are set up, so yeah, the same thing. It will take time the first time you want to run it because you need to install it in your virtual environment here on the Jupyter Hub. So I already done that so once, so it should be a little bit faster. So let's see. So you see, it appears the same way. You click on no desk. Normally, magic, miracle occurs. And you have a computer in your browser. So you don't need, so the same thing. So yeah, I think use this one. Hopefully it will work. No, it's not local. It's completely in the cloud. So, and you have the same interface. So you have the shell here. Let's put it, you can run FSL, SPM, everything on the cloud. So as I say, yeah, you have the menu here. You can run it the same way.
Is it faster?
So no, it's not faster because as I say, so when you use Docker, it will use the resources of your computer. So here it's limited. After you can run it, if you have access to some resources, you can put it on it and it will use all the resources. It's a little bit like using the cluster. As it's a container, it will use the resources you give. So here, I think, so I asked Stefan because for today, because it's only 10 gigabytes of data, so it's not much. So he increased increase for this tutorial to 20 gigabytes, and it's using 2 CPU and I think 8 GB of memory, something like that. So you can run basic stuff, but if you want heavy stuff, you need to think how to plug it to a cluster. But this is a way to meet. Okay, so and yeah, that was the thing. I think
How do you increase the size if you want to increase the size
of what?
of the device that you storage? Can you increase the size
Of that?
of the storage? Yes.
I think that is limited to the space on your computer. So you can put everything. So you need to be careful. If you don't have enough space, you will fill the space of your computer. But there is no limitation to the space.
It says it's over, it says in the mouse. Are you sure you want to open it? So when I was hoping.
Yeah.
Yes. I'll show you.
Yeah. Well, so the point is just to get you. So either you have Docker and you understand your computer, it's working, or not. And if we cannot solve it, we can use the cloud version of it for people that, or I cannot solve the problem. We can have a solution for that. Yes. You cannot, Marcela.
I get understand them.
Why?
My idea, I have like that.
It's you, it's it. You cannot use it. So if people are happy with the Docker, for me, if you have questions, I'm here. And if you have problems, we can solve that now. Like this afternoon at 2 p.m. we talk about real fMRI. Okay.